Hello all, I'm Abhishek and welcome to this very short introduction to the quantitative section on the CLAT. This section is meant to test whether you possess some basic arithmetic ability and manages to send a shiver down the spines of even the most brilliant students. But you will see, with a little bit of smarts and work, you can easily breeze through this section. The quant section on the CLAT is composed of 20 questions and tests you on elementary high school mathematics. As you will see, this section is entirely based on a few broad math concepts. So let's begin. The first is number theory. Number theory usually tests you on concepts like prime and composite numbers, LCM and HCF, surds, indices, powers, rules of divisibility, and arithmetic identities, amongst others. This is usually the most easy concept to master, and you should look to maximize your score on questions that test you on number theory. I hope that you were able to attempt the quiz before watching this video. We will be discussing the answers to questions that are given here briefly, but I assure you that more detailed solutions will follow soon. As you can see, the question here is picked up from CLAT 2016 and it's a fairly easy one. It asks you the number of 3-digit numbers which are multiples of 9. This question can be solved with a fairly straightforward approach. You know, the first 3-digit number that's a multiple of 9 is arrived at when you do 9 into 12, which is 108, and the last number is 9 into 111, which is 999. So you can see between 9 into 12 and 9 into 111, there are 100 numbers. So the answer to that is C, 100. The second, and I think the most important part, which forms the basis of all problems that are tested in CLAT, is linear equations. Most problems in the CLAT are posed in the form of a word problem and requires you to frame and solve a system of equations. If you are able to identify and transcribe the problem into a system of linear equation, solving it is a breeze. The question here again is a straightforward one. A father is 3 years older than the mother and the mother's age is now twice that of the daughter's age. If the daughter is 20 years old now, then what was the father's age when the daughter was born? If you take the daughter's age, you can see that the father's age and the mother's age is described in relation to the daughter's age. So if you assume the daughter's age to be x, the mother's age is going to be 2 times that, which is 2x, and the father's age is going to be 3 years more, which is 2x plus 3. You know the daughter is 20 years old now, which means the mother is 40 years old, and the father is 43 years old. So when the daughter was born, which was 20 years ago, the father would have been 43 minus 20, which is 23 years. So the answer to that is D. The third most important topic is that of commercial arithmetic. It includes profit, loss, cost, selling price, discount, profit and loss percentage, etc. Now, again, these kind of problems can be solved by forming a system of equations. But why I have it here is that there is some terminology that is to be picked up with respect to these questions. What exactly constitutes profit or loss percentage? What is selling price? What is cost price? What is discount, etc., etc. Again, this problem is a fairly straightforward one. I cannot get into a detailed solution, so I will give you a hint. The question asks you to find how many oranges should this man be selling for him to make a gain of 10%, right? You know that the selling price of an orange is 1 rupee. That implies the cost price should be 10% less, which is 0.90. That's the start of your solution and you can work from there. The fourth most important topic is geometry, which has topics like areas, perimeters, surface areas, and volumes. Again, this is straightforward, and in case you encounter any word problems, they can be solved by forming systems of equations. But the reason I have this topic listed here is because it is especially prudent for you to learn and pick up formulae that can be directly applied for areas, for surface areas, and for perimeters, etc. The problem here again is a very simple one. There's a square field that has an area of 324 meters. You need to find out the perimeter of the field. Now you know the area of the field is given by the square of a side. If you take the side to be, say, S square is going to be 324, which means the length of one side is 18. And the perimeter is 4 times that because there are 4 sides. So it's 4 into 18, which is 72. The last topic that I've listed here is probability and counting. Now, this topic is not really tested a lot on the CLAT, but then they do tend to ask questions on probability and counting. The property that you're dealing with here is just elementary probability theory. And in counting, you have permutations and combinations. Again, it's very instructive to understand how these work and have wide range of applications, even in problems that do not deal with counting directly. As you can see here, it's a fairly simple problem. There are 12 defective pens that are mixed with 132 good ones. That means now you have 144 pens, and you need to find the probability that a pen that is picked out at random is a good one. It's fairly easy. The event you're looking for is picking a good pen, which is you have 132 of those. And the total sample space is 132 plus 12, which is 144. So the property you're looking for is 132 by 144, which is 11 by 12. So the answer there is B. And the last thing, I think a lot of students jump the gun to get to this part, is learning heuristics, shortcuts, tips, and tricks. Remember, they can only be applied effectively and efficiently only if the basic concepts are properly understood. That's all for this video. I hope you will join us for a lot more videos that we'll be doing on quantitative aptitude. Until then, good luck.